All right, my name is Ryan. I am a engineer at Out2, and I'm going to be talking to you guys today about Synthall, one of our newest products here. So for a little bit of background on me, I'm Ryan Hitchcock, as I've said. I work at Out2. I've been there for about 2 years now. Before that, I was a programming, 3D modeling, and 3D graphics teacher at a school. And currently, I'm the lead engineer and product manager for Out2's Synthall project. I'm also currently an SJSU student pursuing software engineering. So just cover the agenda for today. I'm going to first be talking about machine learning, kind of its overview and its applications in the industry and what it's being used for currently right now. I'm also going to talk about some problems and drawbacks of machine learning that people may run into, or you may run into if you are ever using machine learning to solve any of your problems. Kind of piggybacking off of that, I'll then talk about synthetic data usages and what synthetic data can do for your machine learning pipeline and what that can mean for your machine learning process. I'll show you our solution, Synthall, and how we've solved some of these problems and what we've done to make it easier on developers. There's one thing engineers are really good at, it's making their own jobs easier. And then after that, I'm just going to give a short demo of Synthall so far and what it looks like. So to begin, I want to talk about machine learning. Machine learning in a nutshell is the process of giving a network enough data and information about that data that it can eventually interpret the data on its own. So for example, if you wanted to recognize people in an image or cars in an image, you would give the network enough data of pictures of people, pictures of cars with those cars and people marked, and eventually, given enough time and given enough training, the network might be able to understand what a person is or what a car is in these scenarios. Is it AI? Yes, in the terms that we currently talk about it today. Is it AI in the terms of robots that can take over the world? Not really. It's more like a fine tuning of a large quantity of variables. All of the variables that come in and data that comes in through an image is very complex, and there's a lot of them. Three or four variables per pixel, right? And so we need to fine tune a network to understand how to interpret that data so it can understand where people are and where cars are and so on and so forth. Machine learning is growing really fast. Just for some context here, it's often seen as sort of a magic pill solution to the public. You need to solve a problem, solve it with machine learning, right? Every startup in the world seems to be doing it these days. Everybody wants to hop on board. It's a very fast-growing field, and it's very popular. It's also very underexplored, I think, at least. A couple of big people that are doing it right now are Google's Waymo and GM Cruise. They're part of the self-driving initiative that everyone else here in Silicon Valley is also trying to take part of. And they're using machine learning to understand what the surroundings are around a vehicle. So I talked about people detection and car detection. That would be really important to know in reference to your car, so you can understand where to steer your vehicle and where to do that automatically. Same with GM Cruise, they're doing the same thing. It's sort of an arms race to see who can produce the best and most efficient, safest self-driving vehicle on the market. It's also used in medical fields as well. There's been a few studies showing machine learning doing early detection of illnesses or tumors in brains that can be identified much quicker and much easier than some doctors can do it. So there's a lot of applications ranging from everything that machine learning can be used for. So what is the machine learning process and what does that look like? How do we go about that? So first off, you generally pick a machine learning model and you end up feeding enough labeled data into the network to train it, to get it to understand what's in these images. And then obviously after that, you use the output in your code, and now congratulations, you've detected cars on the road, right? But this is a very simplified process, and these steps that I've shown here are very complex under the covers and use a lot of very intricate processes to make this happen. Now, there's problems associated with all of these, and with some of these steps we've covered with other products at Out2. But for now, I want to talk about the part about feeding labeled data, because getting the data and having it labeled is not easy. It's not easy at all. Because there's a lot of things to detect, and from people and animals to planes and trains, cars and bikes, to tumors and brains. I actually didn't mean that to rhyme, but I kept it when I noticed it rhymed because that was funny. And businesses' use case drives the specificity of what a network needs to detect, right? Like, it's not always just, I need to know where the people are. It's, I need to know where the people are, what they're doing, and what color hair they have or what they're wearing, right? And this isn't something that you can easily find online, and is most often something that needs to be done by the company or the person themselves, and can get very complicated very quickly, especially when you need tens of thousands of images, hundreds of thousands, even millions, to even get a network started and get to start to recognize what these things are. So let's say you have to go out and gather this data on your own. You'd have to go out and take pictures in the scenarios that you need. What do you need to be detecting? Is it cars? Is it people? Is it snails? Is it rocket ships? I don't know what you're detecting, right? So you need to gather this data and you need to have it labeled. Labeling is arguably the harder part in the end, because although you do have to go somewhere to take the pictures, I'm going to just play a quick example here of what a labeling process might look like if it wants to be done accurately. We see somebody starting to draw some lines around this shape of a car overhang or something. Now, I don't know if you can see this very well. He'll probably zoom in a second here. I guess it's not playing very well for you guys. But essentially what he's doing, he's drawing a very, very slowly, drawing a line around the shape of this object. And that's for one object. And that has to be done 10, 20, 30 times per image. And then at least 10,000 to 100,000 times in a data set, because each frame needs 10 to 20 to 30 different segmentations in it. So segmentation is basically labeling and marking out an area and saying, this area is a person, this area is a car, this area is a rocket ship or a snail. And there's data sets that do exist online, which may be useful for your purposes, but a lot of them are only boxes. You only end up getting things drawn around, a box drawn around a person or an object. And that's maybe useful for your purposes. But like I said, in a business case, you don't necessarily want to know, everybody can figure out where people are. We need to figure out where people are, which direction they're headed, what they're doing, what they're wearing, all these different things. And that is not represented in these data sets. You can see these people marked in the image here. And there's obviously a lot. Somebody spent a lot of time labeling this one image. We can see the people marked here, but we don't know anything about them. We don't know what's going on, what they're doing. Do we need to know anything about them, right? So we don't extract a lot of information from this. So eventually you get to the point where if you've done this long enough, you think, what if I just generated my own synthetic data? What if I created it myself, right? Instead of going out and taking pictures and labeling it painstakingly, that'd be something that I'd want to do. And what are the benefits of me doing that? Well, first off, we don't have to gather the data anymore. We can generate it in our own home, in our own business, on the computer. And likewise, we don't have to label it either, because if you generate the data with a computer, you can generate the labels at the same time. So you don't need to have this complex interaction. You just generate the data and there it is. It's ready for you. But arguably the most important step is being able to change your data quickly. I have a little diagram here. The left representing the process of gathering and labeling it yourself without synthetic data. You'd start off gathering data and labeling it, and then you'd go through and train and evaluate your model, get your network to try to learn what things are. And inevitably, if you're a developer, you know this to be true, that nothing works the first time. It always breaks, it always doesn't work, and you always need to change something. So you'd end up going back to the data gathering and labeling process, and you'd need to start essentially all over again with the new information but all over again, gathering data and labeling. With the process of generating synthetic data, you might even want to start off paying a fixed cost to get some real data in the beginning. It wouldn't hurt, right? But at that point, you can generate some synthetic data. You could go in and train and evaluate your model, see how it's performing. Is it detecting at the accuracy that you need? If it's not, you can go back and generate more data to fine tune what you want it to be seeing. And you can generate data specifically for the problems that you're having. And this is sort of a perpetual feedback loop, right? You can generate any data that you need to produce any result that you need. So obviously, we're not the first people to think of this, right? What's the current state of the art? What are people doing now? Well, Google's Waymo has something called virtual miles. They do what's called virtual miles, where they have essentially the same network that's running in a real car running inside a virtual environment where cars are driving on the road. It's all done in real time. They can segment this stuff out, find the things, and they can teach their cars to drive based off of what it sees in the computer world, because we can represent the real world so accurately nowadays in the computer world. NVIDIA was doing the same thing with synthetic data, generating images for cars. They were doing specifically cars as well. And you can see here something that's actually kind of interesting. You'll notice in the bottom right-hand picture here, you can see cars, and they're sort of like on this big plank of wood or something, and these random geometric shapes are floating around in the background. Now, this brings up something interesting about synthetic data, in that it's not real data, and it doesn't have to be, right? You can generate these things with whatever you want in there. And the benefits of that what NVIDIA found was that they were trying to train these networks on this data, and they couldn't seem to get it to stop thinking that other things were cars, and they didn't know why. And so what they started to do is they started to just throw random geometric shapes in there and didn't mark them as cars and mark these as just random stuff. And eventually what the network learned, it was like it noticed to not pay attention to the random information that comes into a camera or that you see in the world, but to look for cars specifically. And that was something that really made the network better and be able to understand and locate these vehicles. Does it completely replace real data? Current studies show that synthetic data is best used alongside some real data. But I want to go back to that NVIDIA paper again, called Training Deep Neural Networks with Synthetic Data, where they said, using synthetic data alone, we have trained a neural network to accomplish complex tasks like object detection with performance comparable to more labor-intensive and therefore more expensive datasets. So you can see here in the images, it's split into two sections. The left section was a network trained on real data and real cars and real labels that people spent a lot of time working on. And the one on the right was a network that was trained purely on the synthetic data that they used to generate for these situations. And you can see it's almost identical. They were able to almost perfectly recreate this network in most ways. So that's all great. That looks great. We see that synthetic data is going great places, but what's the problems? What things are the downfall of the current state of the art? Well, currently for the developer himself or herself is it's application specific, right? Like Google's virtual miles, it can only be used with Google's networks, and it's built for Google's networks and their cars and what they're doing. And it can't be used for other machine learning applications. If you wanted to detect snails in your garden so that you can get rid of them for some reason, you can't use virtual miles to do that for you. It only does cars on a road. And furthermore, even if somehow you could use Google virtual miles, it's all proprietary and internal anyways. You can't touch any of this stuff. Same with NVIDIA's and all these other places. And what can we do to make it better? Well, according to what we've found, any solution would have to really be flexible with what it can do. It would need to be expandable to fit, all the needs of the people that wanted to use synthetic data in their projects. If you need to detect cars or spaceships or rockets or snails or whatever you're detecting, it should be able to cover all of those bases in a way that's easy for someone to use. Like we talked about earlier, we need to be able to quickly iterate. One of the most important parts of making sure that a network is working is checking it and getting feedback and moving forward and changing. And it's an often slow process. So we want to be able to quickly iterate data so we can push that process along. We don't have to work so tightly on that anymore. The last thing is we want to provide the same quality of data that the state of the art already provides. We don't want to pull back in the quality just because we're trying to help more people. We want to maintain the same level and add to it, right? So how can we accomplish that goal? What are the different things that we've thought of here to kind of go about this? Well, we can utilize the power of AAA game engines. That's what Waymo is doing, Google's doing, NVIDIA was doing, right? They're utilizing game engines to render these things for them, which is very cool because the state of technology as it is, games are becoming very realistic and very hard to tell sometimes from real life because of our computational levels in computers. So we want to be able to utilize that when we're generating these things because it will allow us to do it very quickly. We want to be able to use a modular system that can be expanded and added to, right? We want to be able to add pieces to this and change it to fit exactly the needs that the developer wants. If you want to add a feature so you can detect certain parts of people, or if they're on their phone, or if their phone's actually off, you can change it to detect that kind of thing. We want to allow it to be programmed so you can write code to do this for you and all this stuff so that all these things can be automated. And maybe this last part would be to allow easy access for changing parameters without programming. Part of quick iteration will require us to not rewrite code and recompile code and redo all these things. We want to be able to change these things on the fly as we're generating. So we get to our main point here. What is Synthall? Is it useful? How do we use it? What does it look like? And what does it do? Synthall is a platform that quickly generates programmable synthetic data for machine learning. It uses a system of programmable modules for generating that data. Now, what do I mean by modules? Well, we think of modules in two different ways here. We think of different modules as data modules and scene modules. Data modules being the things you want to detect, and scene modules being the environments you want to detect them in. For the data modules, you might want to detect people or cars or animals. For scene modules, you might want to detect a city or a forest or an office or whatever kind of situation you think they'd be in. So you might find people in a city, or you might find cars in a city, right? And that'd be data you'd want to recognize. You might find people in a forest, or you might find animals in a forest, right? And so those situations that you can probably actually get data for in real life if you went to go take pictures. The process would still be slow for labeling, but those are the things you could do. Something that might be harder to do, though, is if you need to detect animals in a city. Say the tiger got out of the zoo today, and you need to be able to detect where it is and where it's going and how to stop it. It'd be very hard to get images of that to train a network to do that, but we can very quickly generate data of that kind of situation safely. If we want to detect cars in a forest, that might also be something that's a little bit harder to find, a little bit harder to take pictures of, but something that we can still very easily see and generate with synthetic data in Synthall. Synthall is also entirely programmable. Using the C# programming language, you can make your own custom modules using the Unity engine. So like I talked about using AAA game engines, in this case, we allow you to use Unity as something to make modules. In this case, you'll see that we are putting a car on the road. We can generate different things like that. If you wanted to create something custom to work with the Synthall engine, you can use Unity to do so. And this allows developers and even creative people to move on to the scene here and really make a difference with the synthetic data that they create with the skills that maybe were not useful before. It's also not limited to what it can do. Like I just talked about it being able to program. If you want to detect snails, like I've been talking about this whole time, in your garden, so that you can finally grow some tomatoes, Synthall can generate it. That's something that you can do very easily, very quickly. Garden scene, snails, plop them in, generate hundreds of pictures. You already have it. They're already labeled. So why is this better? What are some of the more pieces that makes this good? Well, Synthall takes care of a good portion of the hard work required in making synthetic data. It exports to common data formats. So we have supervisedly here, we can export to images. Any data format you need, we can export to. It's also one of the programmable features as well. If your company or your personal project has a custom data format for your machine learning process, that's something that you can script, and you can decide how you want the information to be given to you. We also do segmentation and segment filtering. In the beginning, I was showing a little bit of kind of drawing shapes around objects and characters. We can segment those characters for you. We can detect things in different ways if you'd like. That is another scriptable piece. And we can do filtering of that stuff for you. So add complex interactions for understanding what data we want and what information we want and what we don't want to keep. And like I talked about before, we have an on-the-fly parameter interface. So if you see here in this image, we can change parameters. There's only 3 in this case here for this one. But we can change parameters about the generation and the things we want to change to maybe make it easier for the network to understand and not have to reprogram any of our code. So I'm going to go ahead and do a live demo here. I'm going to pop up Synthall and get this ball rolling so we can see what's going on here. Let's see. All right, so I got Synthall on the screen here. So this is what Synthall looks like when it starts up. It's not super complex, but it's not super simple. We can see when we start it up, we have a few different things to look at. If you are a Blender user, you might notice that this is the default color UV map texture from Blender. But essentially, it starts up with a completely blank slate. You can generate whatever you need going here on forth. So when setting up this demo, I was thinking, what different things would we want to do here? What would be something unique? What's something you can't get a lot of images of? And this being a part of the Unity environment and the Unity game engine environment, there's a community of things already created for Unity itself that can be repurposed for generating synthetic data, which turns out to be very convenient when you need to do something quickly, right? So we were exploring around, and we found a Western saloon and thought, that's not something that we can find very easily in the real world and take pictures of and label it, right? So I'm gonna go ahead and load that module in here. All right. So we can see that I've loaded the saloon in. I'm gonna hit test frame and get a few frames up here. You see that looks like some different security camera positions of what it might look like to take pictures inside of a saloon. All right. So this is what we call the scene module, and we can tell what it is by loaded. I don't know if you guys can see this here on the screen, but it says current scene is saloon. That tells me what module I have loaded. And we can click test frame to kind of check out what this environment looks like. We also have the ability to sort of explore and go around if you wanted to check out different areas to see what kind of information you're getting here, just for debugging purposes. So it's great. We have a scene module there. We are going to work on a business that's going to be detecting something inside of a saloon. So maybe we're detecting people. Everybody loves to detect people, right? So let's get some people in here. So I loaded a data module this time, and we can see that it populated over here in this interface down here called people demo. And I can turn this off and test frame, and there will be no people. And I can turn it back on, and you might see a person every once in a while. Here's somebody on the stairs. And when I'm hitting test frame here, I'm getting sort of feedback of what these images might look like before I create them. Now, I talked about being able to change things on the fly. With this demo, at least there's not as many parameters for us to change. The main one here being the number of people I want to generate in the scene. It's currently set to 10. I'll set it to 20, generate another frame. We can see we're getting a couple more people in here. If I explore the scene, you'll notice that there's 20 people being generated in this room. If you wanted to be 20 people per frame, that can be programmed and you can have that happen. I have a couple of other values here that aren't really doing anything but showing that we can have multiple variables and values being passed into this for this demo. So that's great. We have these people being generated. They're being placed in the scene. We can see them moving about a saloon here and we can detect them. But we haven't seen the labeling yet. We haven't seen what it looks like for these to be labeled. So what I want to do is I'm going to actually generate something live here. And I'm going to call this Saloon Humans. It's a popular phrase in the office now. And I'm going to just generate 25 images, not to take up too much of your guys' time here. And generate to here. All right. So I'm generating. You can see it runs through 25 images even before I can finish saying that's running through that many. So about 5 seconds maybe. Now let me get open the actual images themselves so we can take a look at them. Saloon Humans. All right, so I've got our Saloon Humans on the screen here. So we can see a few people on the screen. Now I'm gonna go ahead and go to the next frame of this here. And we can see that these people have been marked and identified for us. And now in our case, for this generation process, we have marked them just with colors, and that's how we distinguish. But these can be marked with metadata, and tagging things and colors can mean something when you export them to different kinds of export formats. So we can see there's 3 people in this one. There's multiple people in this one. Looks like there was one person in the top right-hand corner. That might be something you'd filter out because that little information might not be something you want to feed to your network. We can see this person here sort of behind a pole. And this kind of stuff is important because how would you label this in the real world? Would you mark what's actually there or just what's behind the pole? If you want to remove people from an image, if you're doing some sort of image editing thing. In this case, here, let's go. Or see, we have a foot here. This segmentation is actually really dark. I don't know if you guys can see it. That's the color the network chose. I apologize about that. Let's see what else we got. So we got people behind people. Like in this case, we have this person standing behind a railing. We can see that we have pixel perfect accuracy. Each pixel that contains a person is displayed here and marked, and a pixel that does not have a person is not marked. So that's just sort of kind of the rough overview of what we're doing with Synthall and what Synthall can do. Let me go ahead and close this out. Hide that. All right. So I'll close out Synthall as well here. So as you can see, Synthall can do a ton of different things. It can be programmed and expanded to make whatever you need for your synthetic data purposes and help you train your network better in the end. I want to move forward here to kind of open up the floor a little bit to the rest of everybody else. See if there's any questions anybody has. I know we have a chat open. You might be able to ask there. I think you can also raise your hand and ask to speak to me directly if you'd like to.
Okay, so for people who want to ask questions, please raise hand so we can unmute you. While waiting for our audience to prepare their questions, I do have a question that is not relative to Synthall. But Ryan, can you share how would you combine your presentation with your camera, like your image?
So what do you mean when you say combine my presentation with my image?
So how do you view your live image, like your camera view on your presentation?
Oh, how do I compare what you guys just saw to what it actually is?
Yeah.
Oh, okay. Yeah. I guess I could put some things in the chat. Are you asking about like resolution problems, or was things not streaming
No,
completely correct?
I'm asking about how do you put your video on your slides?
Oh, how did I do this in particular?
Yes.
I'm using a software called OBS, which is Open Broadcasting Software. It's used for people streaming to Twitch or to different platforms. And I basically just run it through a virtual camera and then shove it through Zoom.
Awesome. Thanks. Yeah. I see somebody is raising hand. Aris, can you unmute Julie's phone, please? Iris?
Yeah, I think I have already unmuted Julie. So
Hi. Hi, this is Julie. Can you hear me?
Yes, I can hear you, Julie.
Hi, Ryan. Thank you. I just have a question. The demo you just showed, when you put more than one person into the room, are you able to for example, put this person on the stair, another person in front of a chair, like a more specific location?
Yeah, so that's a great question, Julie. One thing that we thought about a lot when deciding, how scenes work and how that works when placing the data in. When we expose the programmable features for placing things in scenes, we expose it in a way that allows you to choose a lot of different ways to do that. So, for example, something that is always there in a scene is the ground area, or the area in the air, or the ceiling or the walls. But each scene can do something a little bit more specific. If you want to create a module specifically for the saloon scene, the saloon might expose the stairs area if you want to generate people on the stairs. So the scenes can sort of define where you can place things, and then there's also general ways of placing things in every scene. Does that answer your question?
Yes, thank you. And where do you get the source data of the data you call? I remember you called it data set and the scene set. Where did you get that original data?
For what I just showed you, or for one of the networks that I showed you in the presentation?
You can just as an example, you just in your demo,
Yeah, so that was something I generated right then. Synthall can be something you can go to our website, how2.ai, and get contact info there. But all the data that I showed you is something I generated live on the stream here.
So those data, they're not, because you're not taking pictures, right? So I'm just wondering, because the first step is to take a picture, and by using this software, we no longer need to take the picture, rather than using those diagram or something similar as taking a picture. So where those are coming from?
Where the images that I generated coming from?
Yeah.
Those images were created completely on the fly when I hit generate. It's a unique image. It's never been seen before, based on the parameters I set for the game engine to display. So that picture came from nowhere. It came from just the computer itself.
Oh, okay.
Yeah.
So this software basically needs to have a very big data set in order to be used in the tool to generate a different scenario, right?
You don't need any data sets to start with. It's all completely computer generated. You can, much like video games happen nowadays, if you want to create an image of something, you can create it all virtually. And a lot of this is already set up for you. So like the saloon thing that I did was something I got off the Unity community area. where somebody had created this saloon and I just repurposed it for a scene module for use within Synthall. So I didn't actually have to start with anything. I just had Synthall, and then I grabbed the saloon, and I can create as many images as I'd like with it.
Oh, okay. So this creating image, is it the step the user has to create, or it's already included in the software?
It's already included. Yeah. The image, creating the images, labeling it is already something that happens automatically for you.
Okay. Thank you, Ryan.
Yes, of course. Thank you for your questions.
Iris, I think Cole Roche is raising hand. Can you please unmute him or her?
Yeah, I think.
Yeah. Hi, do you hear me?
Yes, I can hear you.
Thank you very much for your presentation. I have a question. If let's say we have some annotated images, and there are some couple of objects that we'd like to add. Can Synthall be used to add objects to an image?
So let me see if I understand your question correctly. You have pictures that have already been taken and things that have been labeled in that image, and you want to use Synthall to add new information to that image.
Correct.
So in this case, Synthall's use case is for creating entirely synthetic images. So that's a great question, though. That's certainly something we'd want to consider. But that in and of itself would probably take a machine learning network to understand what your image is first for us to put things in it. So in Synthall's case, we're creating things from scratch without something given to it.
Okay.
Yeah.
Thanks.
Mm-hmm.
Ryan, I think,
Yes.
while we're waiting for more questions, do you have a trailer video to play?
Yes, I do. I can play some for you guys. Give me 1 second. Let me bring this up here. All right. Let's see if I can get the audio to come through here as well. Here, I might come out of OBS and just share it directly through Zoom. Okay. So on our Out to YouTube page, we have many things posted. One of them being the video that I'm going to bring up for you guys in a second here. Let's see. See, Alex, if you're in the chat, I am struggling to get to the Out to YouTube page here. I don't know why. I'll turn my video back on.
I posted the YouTube link there.
Okay.
Do you want me to play it through my screen?
Oh, sure. Yeah, that'd be great.
Actually, I don't know if the audio would work.
Okay, let's see. I have some cool audio routing stuff going on over here. So
should I just try it out on mine?
Yeah, go ahead and give it a shot. And then if it doesn't work, I'll have something set up by the time you're here.
Sounds good. That's low quality on my end. I don't think there's audio. Sorry, guys.
Yeah, I'm not getting any.
Oh no, feedback. Yeah, Ryan, if you want to annotate this verbally. Can't hear you, actually.
Well, can you hear me now?
Yes.
If anybody has any questions, feel free to ask. We're just pulling time here playing our videos. Yeah, so I think Alex put the link to the YouTube video in the chat here. So if anybody wants to take a look at it, it's sort of some of the stuff that I said compressed very short to like under a minute. If that's your deal.
I have another question.
Yes, Julie.
So in order to use the software, what kind of machine or server I need to have? For example, a database server, a laptop, and application server, something like that.
Yeah, so currently we support both Linux and Windows systems. I just ran this right here and this meeting on my laptop. So you don't need too powerful of hardware to get this going. Game engines and 3D rendering have come very far, so we're able to do that pretty well. So just Windows or Linux on your personal computer is something powerful enough for you to do it.
Any database I need to install?
Nope.
Okay, great. Thank you, Ryan.
Good question. Thank you.